Alright, this is the last set for the 7.2. There's a lot in 7.2. We introduce multivariable functions, first derivatives, first order, second derivatives, which would be second order partial derivatives. Alright, in this last set we're going to do an application. We're specifically going to look at using the first order partial derivatives in an application of marginal analysis. Now, it works the same way as we did with the one variable case. The difference is, though, we've got two options. Remember, it's the multivariable function, so since we'll deal with two variables, it would extend to 3, 4, 5. You just have three variable function, you have three options, three partial derivatives. We're only going to do two, and so remember, we can only look at one change at a time, and so it just depends on what's changing. And for our marginal analysis, it's always going to be the change of 1 unit. So either the x value is changing by 1 unit, or the y value, so not at the same time, one or the other, not both. And again, the analysis part, the explanation, is just as important as getting there. So remember, it's an approximate change in my function, and usually we stick to cost, revenue, and profit when we increase by 1 unit. Again, we're only going to increase one of them. The other one's being held constant. Alright, so I'm going to look at this in an example. Right, a lot of times, again, this is an easy this is an easy example to write as a multiple choice question. There we go. So usually for the final exam, this would have been a multiple choice question in the final exam. Alright, so, suppose we have a company that sells swimming pools with two different sizes. Right? The company's profit is given by the function f of x. So again, this would be the profit function, where x is the number of the bigger pools, the 24-foot pools. Y is the number of the smaller ones, the 18-foot pools. Alright, we were given the following information. We actually don't know what the original profit function was. What we know is when we take the derivative with respect to x, plug 500 in for x, 120 in for y, the value that comes out of that derivative is 1500. And so there are three parts to this. Alright? There's how is the original function behaving? What's the effect on the original function, the profit? Which variable is causing that effect? Which variable is changing? And which variable is being constant at what level? And it matters at what level, because we plug both of these values in. Alright, so first of all, this 1500 at the end, that means the profit, right, because it was a profit function, will increase, because it's positive, by about approximately that 1500. When the x value changes, right, that's the change. So that means the x value is going up by 1. When we took the derivative, right, we held the y value constant at 120. And so that's what's important. That's the second two parts of that. So when they increase the sale of the x value represents the 24-foot pools, specifically from 500 to 501. Oops, not 5001, 501. That 1 unit change, if this would have been 400, it would have given me a different answer. So it's specifically 500 to 501. That's important. And they hold the 18-foot poles constant at 120. All right, and again, that's important because that value was used. We held it constant at 100, the change in profit might have been different. So it's important that this is the level we're at. So those are sort of the three things that we look for. How is my overall function changing? Which variable is changing and at what level, from where, what point to what point, and which variable is being held constant at what value. And it's important what value it is. If this was 100, I would more than likely get a different change in profit. All right, then you go through, again, a lot of times we write this as a multiple choice question, and you check off which one it is. Well, this one doesn't have any change, so that fails. The wrong variable changes. Alright, that says the 24-foot pools increased by 1, 18 pools are held constant that, profit will increase. Alright, C looks like the winner. Again, you should check, right, that fails that. That fails that. All right, so C would be the one we'd select. That's the best choice. All right, so now we're just going to practice this. All right, a local hardware store carries two kinds of hammers. All right, the sales figures indicate the first brand is sold for X dollars, so our X value represents the dollar of the first hammer. The second brand is Y dollars, so Y represents the price of the second hammer. Monthly profit in hundreds of dollars, I've got to remember it's in hundreds of dollars, from the sales of hammers is given by this PXY. Interpret the meaning of this, and by that we mean interpret the meaning of that in terms of marginal analysis. Alright, which again, the interpreting part is the big part of it. We didn't actually have to do any calculus. This is just asking you to interpret what this means in terms of marginal analysis. Alright, so what's changing and what's affecting that change? Alright, so what's changing here is profit, right? The profit function is being affected by our change in our variables. Alright, so we'll start with that. The profit, it's a negative, will decrease by about, remember it's in hundreds of dollars, so it's not $4.5, it would be 4.500 or 450. I'm going to write 450. Oops. Right, because this is in hundreds. Alright, so profit will decrease by about $450 or $4.500, same thing. When, well this time it's the change in Y, right? That says P sub Y. Alright, that's P sub Y. And so that means the Y value is the one that's changing. And so remember what the Y value means? It's the second hammer, the dollar on the second hammer. So when they increase the price of the second type of hammer, specifically from the price it's at, which was $10, to 11, right? That one unit. So they're going to increase the price of the second hammer from $10 to $11. Hold the first type of hammer at a constant price. You can read that, constant price of specifically $27, right? That's what it's being held at. That's what this is telling me, and that's important. So profit will decrease, it will go down by about $450 if they increase the price of the second hammer from $10 to $11, specifically that increase, and they hold the first type the same. They hold it the same, not at any value, but at specifically 27. Again, 27 matters. It would be different if we held it constant at 25. I'd get a different answer. And so that's the three things that we look for in the marginal analysis. Alright, so now we're going to kind of put it all together. Alright, so suppose we have a company that sells two different types of baseball uniforms, modern style and throwback. It's estimated if they produce X modern and Y throwbacks, the total profit will be that profit equation, alright, P of XY, in dollars. Alright, so the first one's just asking you to find the profit at X equals 125 and Y equals, and then explain what it means. So again, that's just be careful, plug in. With these multivariable functions, there's just a lot to them, so you just have to be careful when you plug it in. So negative 2 times 125 squared, 200. Right, so the biggest thing is just carefully type that out in your calculator, and then it's a dollar amount when it comes out. And I believe if I typed it in carefully, it should come out $353,750. Alright, and again, interpret that. There are three parts to the interpretation: the value of the profit, and how did I get the value of the profit. Alright, so the profit is that amount when they sell exactly 125, I gotta remember what my X value is, modern, and 200 throwback. Style uniform. Alright, so again, 3 parts to it. What is it? And how did we get there? Alright, we got this profit by having this many of the X value, which represents modern, right? Modern uniforms, and this many of the Y value, which represents throwback uniforms. Alright, now we're going to use the derivative. Alright, so I've got to go look at my original function and find its derivative with respect to X. Sorry, this is with respect to X. And so P sub X. So again, I only take the derivative of the X values. So there's only 3 X values. Negative 2x squared is going to give me negative 4x. The next term zeroes out because there's no x value. Then the 30xy, its derivative is 30y because those are constants. The x's derivative is 1. And then the last one was 200x, so 200. Alright, then we plug in our value. Alright, so again, we're going to plug in 125 for x. 200 for y, add 200, and just make sure you're careful. If you plug that in, that should come to 5,700. Right, and then again, that's not your final answer. Right, the bulk of this is the interpretation, so you probably get 1 or 2 points for that, but 3 or 4 points will be in your interpretation. And remember, there are 3 parts to your interpretation. What's changing? How's the function affected, what's changing, and what's being held constant, and at what levels, because it matters, because I plugged in both of these values, so it matters that it's 125, it matters that it's 200. Alright, if I pick different numbers, I would get different change in profit. Alright, so first, the profit. It's going up. Increases by about, it's an approximation, 500 or 5,700 when they increase the sale of the X value. X value represents modern. Specifically from 125 to 126, that 1 unit increase. And hold the throwbacks, right, because that's the Y value, constant at 200. And that's important because we use that 200. So it's important that it was held at 200. That's the constant it's held at. All right, and so there's that one. All right, the last one, so this is the last one for this set of notes, is to do the same thing with the y. Alright, so the derivative with respect to y. So I'm going to go back and look at my function and look at the y part. So I'm going to circle the y parts. Alright, so there's the y part, there's the y part, there's the y part. Alright, so there's 3 y parts, and I'm going to take the derivative with respect to y, which everything else will zero out. There's no y's. Alright, so the first piece is negative 12y squared, so that's going to give me negative 24y. Alright, the next piece, 30xy, so 30x, right? 30 comes along, x comes along, derivative of y is 1. So plus 30x, and then the last one is the 700y, so the derivative of the 700y with respect to y is plus 700. Alright, so there's the derivative of the profit function with respect to y, negative 24y plus 30x plus 700. Now I plug my values in, and make sure you're careful, it's really easy to flip x and y in this case. If I were going to do something silly, and I think I have in the past, I would put the x value in the y spot. So make sure you're careful. Negative 24 times the y value, which was 200, and 30 times the x value, which was 125, and then add 700 at the end of that. Alright, that comes out to be negative 350. Alright, so it comes out negative this time. And again, I wanted to pick values so it came up positive, negative, so you can see the interpretation of both. Remember, that's only half the problem. Alright, the interpretation is the bulk of this, and there's 3 things you need to tell me in the interpretation. How is the original function changing, and then what causes that change? All right, so the profit is decreasing, because it's negative, by about 350 when they increase the sales of the throwback, right, because it's the Y value, from, the Y value is currently at 200, so from 200 to 201, that 1 unit increase, and that, again, it's specific because I use that value. And at the same time, we held the modern constant. Right? It wasn't just held constant randomly. It was held constant at a specific value that we use. Well, it was held constant at the 125. All right, so those are the 3 things you need to make sure you do when you interpret marginal analysis in multivariable functions. All right, so we'll wrap that up today here, and then the next set of notes we'll start into is 7.3, which is optimization. All right, so we'll start there in the next set.